What is up, everybody? So we are in 2.2, conditional statements. This is after learning what inductive reasoning is. So today we're talking about conditional and related conditional statements. So again, kind of a funky lesson in regards to, we're going to be writing some sentences, mixing some stuff around. Hopefully we'll be able to make sense, and we'll be able to ask some questions if you get confused at all. So first thing we're going to learn is, what is a conditional statement? Now, a lot of the rules, like the postulates and theorems that we're going to learn throughout this year, are technically considered conditional statements. And conditional statements have two parts. They have what's called a hypothesis and a conclusion. And the way that you can tell which is which is because they are written in an if-then form. So imagine you would have a sentence like, if this happens, then this happens. That's what's called a conditional statement. Conditional statements are really important in computer science because computer science, all of it revolves on whether or not you do something. So if the space bar is pressed, then something happens, right? If the escape button is pressed, then something happens. So a conditional statement, the result is always determined by what you do. So if something happens, then this is the result. That is a conditional statement. And so we could say, if P, then Q. Not if P, then Q. All right. And so P is our hypothesis, so that's the term that always follows the if. And Q is our conclusion, or the term that follows the then. If the hypothesis occurs, then the conclusion occurs, or if the hypothesis, then the conclusion. So let's look at a really simple example. So here is a very straightforward conditional statement. If two angles add to 180, then the angles are supplementary. Now that's something that we learned. Like I said, a lot of our definitions are conditional statements as well. So let's break this down. So if two angles add to 180, that is our hypothesis because it's following our if. Then the angles are supplementary. That would be our conclusion because it's following the then. Very simple, very straightforward. The hypothesis follows the if, the conclusion follows the then in a conditional statement. Now, this looks kind of weird, right? Because there is no if-then. It just says a 90-degree angle is a right angle. Now, this could be written in a couple different ways. So part of the first homework you're going to have for tonight is creating conditional statements. So if I wanted to create a conditional statement here, we first want to identify what is the hypothesis and what is the conclusion. Well, I could say that my hypothesis is a 90-degree angle. I could say my conclusion is that it's right. So if it's 90, I know it's right. So if I were to convert this to an if-then form, I would say if the angle is 90 degrees, then it is a right angle. And as you can see, right, my hypothesis is right here, my conclusion is right here, and they match up directly. Now, the question is, I want you to think about it, could I flip-flop those? Could I say, if it's a right angle, then it is 90 degrees, or then the angle is 90 degrees? Because that's going to be something we come back along to of whether or not, if I flip-flop it, if it's still true. So right now, this is a very true statement, right? Like, if the angle is 90 degrees, then it's a right angle? Yeah, absolutely. All right. So another one. The sum of two complementary angles is 90. Now remember, our definition of complementary angles is they add to 90 degrees. But remember, us being able to say that they're complementary is directly the result of them being the sum to 90. So this one's a little bit tricky where we have to kind of think about the best way to put this together. So technically the hypothesis is the sum being 90. The conclusion would be, or our result of them adding to 90 is we can say that they're complementary. So hypothesis, these kind of go together, and this would be our conclusion. So if I wanted to write this out in a conditional statement, I would say, if the sum of two angles is 90 degrees, I use this symbol a lot for angle, guys, just to speed it up. So if the sum of two angles is 90 degrees, then the angles are complementary. Right? So because we know that they have a sum that's equal to 90, we can then say that they are complementary. That would be our conclusion. So the big takeaway here is, for a conditional statement, the hypothesis follows the if, the conclusion follows the then. If something happens, then something else happens. Or if something's true, then something else is true. All right? Now, with conditional statements come what we call related conditionals. And we get related conditionals when we shuffle the original conditional statement around. So there's 3 different versions. So we have our original version and 3 different ones after that. So 4 total. So we have our original conditional statement. Then we have something that's called the converse, the inverse, and the contrapositive. So let's say that our original conditional statement is, if the measure of angle A is 35, then angle A is acute. That is a true statement. It's an angle less than 90, so we know it's acute. So let's identify our hypothesis is right there. So our hypothesis is angle A is 35, and our conclusion is that angle A is acute based off what it is. So the converse. So what the converse does is it exchanges the hypothesis and the conclusion. So they literally switch spots. The if and the then stay put. So the only thing that's moving is the hypothesis and the conclusion statements. So the converse of this would be, if angle A is acute, then the measure of angle A is 35 degrees. So again, I just took this and I put it after my then. I took this part and I put it after my if. The hypothesis and conclusion just switch spots. Okay, and then again, notice, is that a true statement still? If angle A is acute, then the measure of angle A is 35. Now think back to when we talked about true. In order for something to be true, it has to be true all the time. So yes, 35 is an acute angle, but are all acute angles 35? Something to think about, okay? Up next, we have the inverse. So with the inverse and the contrapositive, we introduce what's called negation. Negation. Okay? And what that does, it negates the original conditional statement. Or more simply put, we usually use the word not, and we insert it, right? So if I said the dog is black, if I wanted to negate that, I would say the dog is not black. Okay? So if I say the angle is right, to negate that, I say the angle is not right. So if I wanted to negate my original, I'm going back to the original order. So the inverse negates the original conditional statement. So here's how this works. So if I say, if the measure of angle is 35, negating that would be, if the measure of angle A is not 35. Then angle A is acute. Negating would be, then angle A is not acute. So again, I'm using the original order of the conditional statement. And by throwing in that not, that's negating it. And then finally, we have what's called the contrapositive. So the contrapositive negates the converse. So the same rule applies where we're going to be throwing in that is not, but now I'm using the converse one instead of my original. So if angle A is acute, negating that would be if angle A is not acute, and then the measure of angle A is 35, then the measure of angle A is not 35. So these two have the same order, and these two have the same order. However, inverse and contrapositive are negating. Okay. Now, one thing you'll notice, guys, is if the original conditional statement is true, then the inverse will always be true. And then if the converse is true, the contrapositive will always be true. But it's not always the case that everything will be true. Okay, there's only certain specific scenarios where everything becomes true. Going back to our original look, right? If angle A is acute, then the measure of angle A is 35. Well, angle A could be 72. It'd still be acute, okay? So if angle A is not acute, then the measure of angle A is not 35. Well, if it's not acute, there's no way it could be 35 because 35 is less than 90. So one more time. If the original is true, then the inverse is true. If the converse is true, then the contrapositive is true, always. But it's not always true that the original and the converse will be true. Because if both of those are true, then everything turns out to be true. And that leads us to what we call a biconditional statement. So a biconditional statement can only be written if the original conditional statement and its converse are both true. So one more time, a biconditional statement can only be written if the original conditional statement and its converse are both true. So let's go back to that supplementary angles term. And the way that we create a biconditional statement is we use the term if and only if. So again, one more time, back to the angles being supplementary. So two angles that add to 180 are supplementary. So let's go ahead and write a original conditional statement. Well, that's my hypothesis. That's my conclusion. I conclude that they're supplementary if they add to 180. So if two angles add to 180, then they are supplementary. That's an original conditional statement. So OC, we'll call that the original conditional. Let's now write the converse. So I'm going to flip-flop this term and this term. Okay. Now sometimes, guys, you have to kind of dissect it a little bit. Like, I'm not going to say if they are supplementary, then they add to 180. I'd probably still keep the two angles part attached to the if. So if two angles are supplementary, now that doesn't happen all the time. There are just special occasions where you maybe have to like keep part of that hypothesis just for it to make sense in the English language, right? So if two angles are supplementary, then they add to 180. Now, is that a true statement? If two angles add to supplementary, do they add to 180? Yes, they do. Okay, so this is also true. So we would say true, true, and because both of those are true, we can make a biconditional statement. Okay, so the way that we would do that is we would say something along the lines of this. Two angles are supplementary if and only if they add to 180 degrees. So if and only if. Two angles are supplementary if and only if they add to 180 degrees. Now, could you kind of mix that around a little bit? You could say two angles add to 180 if and only if they are supplementary. You could, but for me, I like the way that this one stands out a little bit more. So again, this is called a biconditional statement. And you can only write a biconditional statement if the original conditional statement and the converse are true 100% of the time. Okay, so you're going to be doing a little bit of that at the end of the homework. Please let me know if you have any questions. Remember, this video is for Wednesday. There's no homework tonight. The only homework is to take the notes. Thursday, I'll be posting the homework. See you guys in class.